For topic 3, we're going to look at properties of vectors. We've already talked about adding vectors geometrically, so we're now going to talk about a few things involving addition and then a couple of extra little bits of information that are going to help us subtract vectors. Okay, so the first thing we need to understand is that vector addition is commutative. So just as a quick reminder, commutative means that you can add things in any order you want. So if we had 3 plus 4, well, we know that equals 7, but that's going to be the same thing as 4 plus 3, which also equals 7. Okay, so we can add things in any order we want. So if we had vectors v and w, we could take vector v, we could add it to w, and it would be the same thing as if we started with vector w and then added v. Okay, now vector addition is also what we call associative. So imagine you have more than two, so you have 3 vectors. Okay, well, just in the real world, let's remind ourselves of what associative means. We have 2 plus 3 plus 4. We know that's equal to 2 plus 3 plus 4, okay? Well, the associative property is all about how you group numbers, okay? So we could group the 2 and the 3, that would give us 5, and then we want to add the 4, which gives us 9. Or we could group the 3 and the 4, which means we would have to add 3 and 4 first, so that would give us 7, and then we have to take the 7 and add it to the 2, and we get 9. So it doesn't matter how you group your numbers and how you add them. If you're adding numbers, it doesn't matter how you start, how you end, you're going to get the same result, okay? The same thing is kind of true for vector addition. If you have vectors u, v, and w, you could start by adding you could start by adding v and w and then add u to that, or you could start by adding u and v and then adding w to that. You're going to end up with the same thing. Okay, now there is also something called the zero vector, and I want to make sure you understand the difference between zero versus the zero vector. There is zero, the scalar, it's just zero. Okay, it represents nothing. But then there's the zero vector, and the zero vector has magnitude of 0, and then it has no direction. Okay, so if you take the zero vector and you add it to another vector, you're just going to get the same vector back. If you take the zero vector and you add another vector to that, you're still going to get that same vector back, okay? So just keep in mind the zero vector has magnitude of 0 and it has no direction, okay? Now, another thing that we can play around with is this idea of like the opposite of the vector, or a negative vector, or minus a vector, okay? If v is a vector, then negative v is also a vector. It's going to have the same magnitude, just a different direction. So if we have vector v, negative v is going to look like this. It's going to have the exact same magnitude as v. So this is v. This is negative v, or the opposite of v. They're going to have the same magnitude. They have the same length. They just go in opposite directions of each other. Okay, and that's going to be really handy for us in just a bit. Okay, now kind of continuing with this like properties of vectors, if you take a vector and you add its opposite, you're going to get the zero vector. And it's different than adding scalar, like dealing in just the real number world. Okay, when you're adding a number and its opposite, you're always going to get 0. Okay, now that's not the same thing as adding two vectors, but it kind of works in the same way. If you take a vector and you add its opposite, you're just going to end up kind of at the same point. There's no like resultant. Your resultant is just the zero vector. It has a magnitude of 0 and it has no direction. So again, if I were to add these two vectors, what we know about adding vectors geometrically, if this is v, I draw it, I have my initial point, I have my terminal point, and then here, when I end up going back, so I would go this way and then down, I end up right back here. And so there's no resultant vector, okay? So it's just kind of, you're going to end up with that zero vector. I don't want to say there's no resultant vector. The result is the zero vector. There's no direction and the magnitude is 0, okay? So keep that in mind. So if you draw a vector and then its opposite, they just kind of like lay on top of each other essentially, okay? Now, what's really important about this one that I want to focus on is it kind of allows us to subtract vectors. So understanding this idea of the opposite or a negative vector, it allows us to subtract. So let's go back to the real number world again, okay? I am not assuming you don't know what I'm about to show you. I know you know what I'm about to show you, but I just want to kind of remind you of how things work. So when we were first learning how to add and subtract integers, we would have something like 2 minus 7, okay? When you learn how to add to deal with integers, you always learn how to add first, okay? And then we learn how to subtract. And the reason for that is we look at 2 minus 7, and I know every single one of you know what 2 minus 7 is, but back when you first were learning this, this could be confusing. And so we're like, oh, 2 minus 7, okay. So we're like, well, let's think about something we do know. We can rewrite this as addition, which is something that at that point in time you're much more familiar with. So we would say, okay, 2 minus 7 is exactly the same as 2 plus the opposite of 7. Okay, and then we had addition of integers, which was something we were already familiar with. Well, the same principle kind of applies here. We're already familiar with vector addition. So if we have vector subtraction, let's just rewrite it as an addition. Okay, we understand this idea of the opposite of vector w. So let's just take, if we have vector v minus vector w, let's take vector v and add the opposite of vector w. Ends up being the same thing. Okay. So that's what we're going to do first, okay? So I have the same three vectors that we used in the previous example, okay? So I have vectors W, V, and U. And remember, I didn't know how to put the little vector topper on in Desmos. I was short on patience and skill. So go ahead and put your little vector toppers here. You really do need to indicate to your reader that you have a true, honest to goodness vector. And I didn't know how to type in the vector hat here. So put them in yourself, all right? Now, what we're going to remind ourselves of just really quickly is the movement of these vectors, okay? So for vector W, from its initial point, from its initial point to its terminal point, we had to go to the right. Let me not write it so solid. We had to go to the right 1, 2, and then we had to go up 1, 2, 3, 4. So we went to the right 2, and then we went up 4. Okay? For vector V, from our initial point to our terminal point, we had to go to the right 1, 2, 3, 4. Then we had to go up 2. So we went to the right 4, up 2. And then finally, for vector U, to get from the initial point to the terminal point, we had to go to the right 1, and then we had to go up 1, 2, 3. So to the right 1, up 3. Okay? And just for the sake of practice, before we dive into parts A and B here, let's go ahead and just kind of envision this idea of the opposite of a vector, and we are going to do W here. So let's say that we want to look at the opposite of vector W, or negative vector W. Okay. So what we really have to do is we have to change both directions, horizontal and vertical. Okay. So for W, from the initial point to the terminal point, we had to go to the right 2, and then we had to go up 4. Well, for negative W, we're going to do the opposite of that. We're going to go to the left, and then we're going to go down. Okay. So let's say we start here. We're going to go to the left, 1, 2, and then we're going to go down 1, 2, 3, 4. So this is the vector negative W, okay? Notice it has the same magnitude as W, it has the same length, it's just going in the opposite direction, okay? So let's keep that in mind because we're going to use that kind of idea with our subtraction here. Okay, so for part A, we have vector U minus vector V. I'm going to rewrite that as vector U plus negative or opposite of vector V. Now, for this negative vector V or the opposite of vector V, whatever you want to say, let's really think about what we did for vector V. So we went to the right 4, and then we went up 2. So what we want to do here is go to the left 4 and down 2. Okay, so when we do our addition, we're going to add the opposite of vector V. Okay, so let's go ahead and start with vector U, which is the blue color. Okay, we can start really anywhere we want. We just want to make sure this picture kind of fits in this grid. So I'm going to start vector U kind of off to the right a little bit more. So I'm going to start it right here. Okay, so that's going to be my initial. Do I have enough room? Let me go down one more. Let me go down a little bit more. Let's start it like right here. So remember, the movement that we have to make for vector U is we go to the right 1, and then we go up 1, 2, 3. So that's going to be the terminal point of vector U. So I'm going to write this as vector U. And then remember, the terminal point of U is going to become the initial point of negative V, or the opposite of V. Okay, and V, we're going to do it in red. Okay, so remember, we need to go to the left 4 and then down 2. So I'm going to go from this point right here. This is going to be my initial point. I'm going to go to the left 1, 2, 3, 4, and then down 1, 2. And that is the vector, whoa, I hate when Microsoft tries to like make my stuff pretty. I don't want it pretty. I want it exactly the way I drew it. Okay. So this is the opposite of vector V. And then the resultant I'm going to do in black. And remember the resultant, it goes from the initial point of your first vector to the terminal point of your second vector. So this right here is the vector U minus V. Okay. Not too bad. All right. Now let's do the same thing we have for part B. We have vector W minus vector V. Remember W, we have purple. Okay. And then V, we have red. So don't forget that, first of all. All right. Now I'm going to rewrite this as addition. So we get vector W plus the opposite of vector V. And we already know from part A that for vector V, instead of going to the right 4 and up 2, we need to go to the left 4 and down 2. Okay, so let's figure out where we want W to be. I'm going to start W like, well, let me do purple first of all. So I'm going to start W maybe like here-ish. Okay, so I want to go to the right 1, 2, and then up 1, 2, 3, 4. Remember, that was W. We went to the right 2, and then we went up 4. Okay. So that's my terminal point there. So that is the vector W. And then remember, the terminal point of W is going to become the initial point of negative or opposite V. So let's go back to red. So from here, I'm going to go to the left, 1, 2, 3, 4, and then down, 1, 2. So that is the vector negative V. And my resultant, I'm going to do in black. And it's going to go from the initial point of W to the terminal point of negative V. And this is vector W minus vector V. And there you have it. So if you're presented with subtraction, it is easier, I think, to go ahead and rewrite it as addition like we did here. Okay? It's like why learn something new when you already know how to do something. So when you have subtraction of vectors, just write it as plus the opposite and you'll be fine. Okay? In the next video, I think we talk about scalar multiplication. All right?